Good afternoon, everybody. I'm Lorenzo Dassatti, and I'm an 11th grader here in TEDxAOSR. So, my question for everybody here is, what are we doing to save the world? Because just as we've seen in the beginning of this entire presentation, and overall, what we've studied, is that there is a problem afflicting us. Every day, and all these times, we're always seeing how global warming is affecting us. Now we see this in the vegetation, in the ecosystem, and in everything overall. The glacier is melting. Everything is crumbling down. And my question is, what are we doing to solve this problem? Now, one might say, oh yeah, like all the governments are doing something. For example, we have UN meetings every day, summits trying to understand what we can do. Also, why not? There has been something like the Paris Agreement that happened in 2016, but did that really bring us anywhere? Well, I mean, this year we've had the G20, or the European Green Deal. And now, what happened this few weeks? We just had the COP26. But did this bring anywhere? Did this whole entire discussion ever bring us somewhere? Well, I guess this pretty much sums it up. Greta Thunberg, in fact, said that it always keeps on going as a blah blah blah, and the meaning that we always talk about doing something, but we never actually do anything. Now, I have an idea, and my idea is that overall, we have to fake it until we make it, or rather, not fake it until we make it. It's more, do it until you become it. And I decided to appropriate this small little idea and concept that I kind of more or less developed, and I decided to bring it up into our ecosystem, or our community, I could say. And so, how can we do something to become green? Now, before actually establishing this, I always thought about, well, how do innovations work? Innovations such as new technologies, new ideas, new concepts. How do they develop? It's always by looking into the past. So now, let me bring you back in 600 AC. These are the Hanging Gardens of Babylon, built in Mesopotamia. These were built by King Nebuchadnezzar for his queen. And these Hanging Gardens were one of the 7 wonders of the ancient world. Now, they worked through intricate and different types of irrigation systems, slave workers, and all of this combined together made one of the most beautiful gardens in the world. But now, what are they now? This is what they are today. The problem is, obviously, we can't really make them work anymore today because it's barely even foundations anymore. So my question is, how can we actually adapt this in our school? And here are the green areas in our school. By courtesy of AOSR, these are the plans for the entire structure. And as you can see, yeah, we do have big green areas. I mean, approximately we have 1,345 meters squared of green areas. And that is a good number, but how can we increment this? Now, my idea and concept is to actually use the idea of having botanical installations on rooftops. So this is what I'm thinking of. Creating different types of green rooftops all over the school, where it is obviously permitted, and this would actually help us by increasing green areas by almost 50% of what we have now. In fact, we would have an approximately 600 meters squared gain. But why would we be doing this? Why would we be adding extra green areas in our school campus? I mean, does it even make a difference? Well, actually it does. Because what do plants do? Of course, through photosynthesis, we have chlorophyll, which are these particles over here, which, by absorbing CO2, minerals, sunlight, and water, they emit O2. And in this process, they create sucrose, which is used by them to actually survive. And so, actually, photosynthesis, as a concept, is just taking out monoxide, carbon monoxide, which is poisonous for our ecosystem, and bringing it O2, which is oxygen. Now, how can we actually calculate whether this could work? There has been various experiments all over the world, and the closest and most exact number that there is was made through a little experiment made by 2 different scientists. Now, this experiment overall was based on the foundation that, if you've studied chemistry, you might actually think about it and remember it, is that for every mole, which is almost the description of quantity, for every mole of O2, there is 1 mole of CO2, which is gained. Now, how would this work? The fact is that through different calculations, and this, as we can see, is the inside of every single chloroplast, which is what creates chlorophyll and the process overall, is that approximately 0.69 grams of oxygen are produced per square meter every hour. Now, this might seem not enough or quite a small number, but if we calculate how much has already been produced in our school campus with our current green areas, is around 1 kilo of oxygen. In fact, it approximates to 928.05 grams of O2. But now, what happens if we add in these new green areas? With these new green areas, we would have an approximate of 400 grams gained. And now, these might seem low numbers, but remember, this is only what happens every hour. So we have to consider 24 hours of the day, 7 days of the week, 4 weeks in a month, 12 months in a year. Every year, every day, every month, and every week. These are substantial improvements that we can do to our whole entire ecosystem, both in our small school community and overall in the environment. Now, how can we actually build these? The thing is that, obviously, roof maintenance and all of these things might seem problems. But overall, we have to remember is that we can't really just put soil on a rooftop and expect for plants to grow, obviously. Now, the thing is that there are new next generation types of products, especially the ones which are made for roofing materials, which help the development of green rooftops. Now, of course, everything comes to a price, but the price really wouldn't be a problem. In fact, there is so much that is gained through the actual constructions of these. Now, approximately per square meter, this is between a $50 and $100 range, and it's all based on an estimate, especially due to the fact that it's all on the basis of the actual school committee to decide what type of quality and the quantity overall of the product. Now, we also have to consider the fact that we have to multiply this by the overall extensive area of the 500 square meters of area that we might cover. And now, by doing this, we would go in and around the 5,000 or 10,000 ballpark range for USDs. Now, this might seem a little bit of an expense, and of course it is. But we actually have to realize that green rooftops don't just help us to create green rooftops in the sense that we can start planting plants on them, but they actually help the rooftop itself. In fact, as we can see through various studies and research, there is a demonstration of how green rooftops can help the infrastructure overall of a building, since it absorbs 80% of all rainwater instead of the mere 20% that normal rooftops do. Also, it reduces the urban heat island effect, which is something which has aggravated the whole entire ecosystem of school and buildings in general, all over the world. It obviously improves air quality, improves building insulation, since it creates almost a microclimate, where it's never too hot nor too cold. And this is why, overall, this could actually help our school environment. Plus, and it's almost a bonus, is that it actually increases the durability and overall the life expectancy of these roofs, since it increases of almost 300% of the original building materials resistance. Now, for the actual soil in the rooftop garden, obviously there is only one option. And that is, of course, using soil. In fact, we can't really start planting plants on sand or concrete. Now, how much soil would we need? To actually make this calculation, what I had to do was not only consider the square meter, but also consider the depth of every square meter. This is because, as you may know, plants don't just grow on soil, they also have roots. And the best height for roots to grow in is approximately 50 centimeters. Now, why do I say 50 centimeters? Of course, that isn't the best height for every plant in general, but that is the best height for every plant that we could actually plant on a green rooftop. That is because we can't start planting oak trees or pines or stuff like that on our rooftops. We can start planting small bushes, flowers, everything that could be included inside of a botanical garden. Now, overall, even the price ranges for these are around $7,000 to $14,000, but that is just a minimum expense that is needed for the actual creation of things that will just help out our environment. And now, these problems overall are just included in our last final piece, which is, how can we use these places? Well, I mean, yeah, it's just going to be a green garden, but what else can we do with these green gardens? We're just going to look at them? Of course not. I mean, the whole point of a garden is to appreciate the beauty and overall relax in it. So my plan is to actually create these small gardens as a possibility even for students all over the school, meaning elementary, middle school, and even high school students to use these places as both relaxing and places where you can study, or places when you can communicate with friends, or even places where our biology science department can actually start experimenting or use the plants inside of these botanical areas as experimentation processes. Now, my question is, this happened in Babylon. Why can't it really happen right now? The overall possibility of doing these things is just so helpful in the overall general idea of the fact that we're producing oxygen and taking out CO2. That is the best thing that could ever happen by planting plants. And now, also, what could be other side effects, positive side effects, of course, of planting rooftop gardens? Now, definitely one of them is actual animals. This is because we have to consider that by planting these plants all over the school place, we have to understand that there aren't only just plants that are going to stay there, it's also going to be all pollinators, such as butterflies, bees, and all these types of insects or small animals that will start actually living inside of our school campus. And how do these help? Well, they just help by going into our environment and helping pollinating other plants all over the school campus, but not only here. In fact, as we can see near our school campus, there are grand and vast green areas. And these pollinators could just go there and help to create plantations of different types of plants, flowers, bushes, trees, all over our ecosystem, in the school, in Rome, and possibly even in the whole entire world. Now, my question is, if we were able to do this in ancient Mesopotamia, where the only technology available was not even a technology, it was just using irrigation systems where we channeled water from the Euphrates River, and using the power of strength and overall intelligence of the whole entire architect team behind the King of Babylon. Why can't we do it nowadays? We have so much innovation, so much structural progress. Everything that we've always done since 600 AC up until today, up until 2021. This has all brought us up to date. All up to the entire whole possibility to create these rooftops all over the city, all over the world, and all over our school campus. Thanks.